All right, let's get started. Sorry about the delay. Okay. Adrian? Devin? No? All right, so today we are going to start marginal analysis. And this is a new section. There's a lot of stuff from 1324 here. We finally start to do some stuff with revenue, profit, cost, and we're just going to use the derivative, all right? So we need to first get some things established, or I should say reestablish some things. Since this is all in the book, I'm not going to write it all down, all right?
What chapter is it?
This is chapter 10. We are in section 7, 10.7. All right, so we have some definitions. First of all, our cost. So, in 1324, you talk about a cost function. Your company has to, take into consideration different things like, labor cost, maybe the electricity to run your, to keep your building open, things like that. So you're going to have your cost function. We usually represent that capital C of X, right? We've seen that? Okay, so now we have a new definition. This is in bold here, and it's what's called the marginal cost. And the marginal cost is just the what? C prime, which represents the derivative, right? So if we take the derivative of the cost function, we get a new function, and that function is now called the marginal cost. So if you're reading a word problem and it says, find the marginal cost of this, for this company, they want you to take the derivative of the cost function, right? Okay, and then we had in 1324 our revenue function, okay? Now, if a new definition, the marginal revenue, which is the derivative of the revenue function. And then same thing with profit. We have our profit function, capital P of X, and now we have this new definition, marginal profit. And just remember, I did mention this in class, profit is revenue minus cost, right? That's one of the big formulas from 1324. All right, so 3 new definitions, marginal cost, marginal profit, marginal revenue. All right? Now, it also says here, marginal cost or revenue or profit is the instantaneous rate of change of cost or revenue or profit relative to production at a given production level. So it tells you, remember the tangent line, slope of the tangent line tells you at exactly one instant, at an instantaneous rate of change of the function. So how fast it's going up or down, all right, at a certain moment. What was that? It flickered? Yeah. Okay. All right, let's see how this works. I'm going to just scroll down. The last 3 things here are, let's say somebody gives you a cost function, all right? And we wanted to know the cost of producing a certain number of items. Then please recognize that if you wanted to know the cost of producing X items, let's say you're building bicycles, your company's building bicycles, and you want to know how much it costs to build 20 bicycles, you'd have to plug 20 into your cost function, right? So the cost of producing X items is the cost function at X. The cost of producing X plus 1 items, you plug in X plus 1. So I know this seems somewhat obvious, but if I'm producing bicycles and I want to know the cost of producing 20 bicycles, I plug in 20, right? If I want to know the cost of producing 21 bicycles, I plug in 21. The difference between those 2 answers is the cost of producing 1 more bicycle, right? So if I produce 20 and I go and produce 1 more bicycle, that's 21 bicycles, the difference between those is the exact cost of producing 1 more bicycle. Make sense? So that's what this one is. We're going to need this, all right? So now we are going to look at a nice result that we get from the derivative. I know that's upside down. And that is this right here. It says that, you know what, can someone hit the lights, like turn on all the lights? The one on the far left needs to be flipped up. Yeah, that might, no? Worse? Worse? Okay, never mind, turn it back on. Okay, so we have this theorem that says that we have a way of looking at the marginal cost, which was the derivative, and somehow relating that to the exact cost. So here's the formula, if you want, or it's not an equation. It has a squiggly equal sign. I'll explain what that means. But it says, look, if you want to know the instantaneous rate of change of your cost function at x, it is squiggly equals, which means approximately, not exactly, but approximately the exact cost of producing one more item. So this is what we just talked about. If you produce one more, you have to take the difference between these two. In other words, the derivative can be used to approximate for your company. It can be used to approximate instead of having to actually calculate that. We just calculate this. So we'll use this in some problems now. I think once we get into some examples, you'll kind of see how this all goes together. For now, just hang tight. So what I'm going to do is I'm going to bring up a problem from your homework, if I can. So your homework problem is number 33. So what I'd like to do is number 34. And that way, when you go to do number 33, you'll have some idea of how to do it, because I'm going to do this one, all right? So let's read this here. Cost analysis. Can you all read this all right? Can you all see this? Do I need to zoom in? You all all right? Okay, the total cost in dollars of producing, it's hard to read here, X electronic guitars is given to us with this function. So I'm going to go ahead and write this down, because I'm going to take this all off the board in just a second. We have a cost function is 1,000 plus 100x minus 0.25x squared. Sorry, I'm mixing that up in there. Let me move this. Maybe I can move this up just a little bit. There we go. This thing's going to start falling off the desk. Gotta love technology, right? That didn't help. Okay. All right, so look at part A. What is part A saying? Find the exact cost of producing the 51st guitar. Is that asking how much it costs to make 51 guitars? No. Right? Find the exact cost of producing that 51st guitar. So we want to know, if we produce 50, we're going to have a cost, right? We want to know the cost of producing that next one, the 51st one. So how do we do that? What was the formula? Maybe I should write down the formula over here. Yeah, I'm going to put, it's going to be off camera, but the exact cost that I just showed you was C of x plus 1 minus C of x, right? And then the marginal cost is C prime of x. And we said that these two things are approximately the same. Approximately. So what are we gonna plug in here? If we want to know the cost of producing the 51st guitar, I'm going to do the cost of the 51st guitar minus the cost of the 50th guitar. All right? So I'm going to go the cost of the 51st minus the cost of the 50th. Make sense? That will give us that cost of making that next one from 50 to 51. All right, so how do you find the cost of producing the 51st guitar? Or the cost of producing 51 guitars? Plug in 51 into that. And then subtract from that, plugging 50 into that. All right, so we got some calculations to do. And I actually think I did not bring my calculator today. No, it's okay. I have my phone, but you should have your calculator. All right, so this will be, we plug in 51 first. Okay, so this right here, right, is just everything that's here is just that, right? That's the cost of producing 51 guitars. And then we want to subtract from that the cost of producing 50 of them. All right, and for this one, I think I'll actually go through the computation, make sure we get the right answer here. So you have to square 51, multiply times 0.25. So this next line becomes 1,000, and then I'm getting plus 5,100, and then minus, and on my calculator I'm getting 650.25. Okay, so I did 100 times 51 there. And then over here, 1,000 plus 5,000. And then minus, and then same thing, you have to do this calculation. 50 squared times 0.25. 625. Oops, 625. Okay, so everything here is just arithmetic, isn't it? It's just arithmetic. All right, so let me put this all together. 1,000 plus 5,100 minus 650.25. And then remember, when you do this over here, you can either put it all together and get a number and then subtract it, or you can distribute a negative sign through and do them individually. It's really kind of up to you. You understand what I mean by that?
So instead of being positive 5,000, it would be negative 5,000?
Yes.
Distributed, okay.
1,000, 5,100 minus 650 minus 1,000 plus. And it'll be plus 625.
Right.
Yeah, okay. 74.75. You can see the answers are here in blue, all right? It's because I'm using the instructor copy of the book. So that's reassuring, right? But we had to do some calculations here, right? And there was some room for error. We could maybe miss a sign or mess something up, right? We get 74.75. So for this particular company, if they want to produce that 51st guitar, it's going to cost them $74.75 to produce that 51st guitar. Now, what if they wanted to produce another guitar, like the 52nd? Is it going to be the same? Not necessarily, okay? So everything is dependent upon this function. And so we cannot assume that producing each guitar is equal each time, each step. It might be cheaper in the beginning to produce the first maybe 20 or so. Then after we get to a certain point, it gets more expensive to produce more. All right, so that's the exact cost of producing that 51st guitar. Now, part B says use the marginal cost to approximate the cost of producing the 51st guitar. Pardon? Nope, we're not rounding. We're using the marginal cost. So remember, the big idea right now is that the marginal cost can be used to approximate this, all right? So we are going to approximate the exact answer with the marginal cost. So what is the marginal cost function? It's the derivative of this, right? So first thing I want to do for part B is I want to find, you know what, I'm going to erase this since I left that up there. Let me find for part B the marginal cost function. So for part B, the marginal cost function is C prime of x. All right, let's go ahead and do that. C prime of x. So you have to take the derivative of your cost function. That one right there. So we can do them individually, can't we? What's the derivative of 1,000? 0, because it's a constant, right? What's the derivative of 100x? So the 100 is just going to come for the ride, right? And you take derivative of x and you get 1. So that's just 100. And then we have to take derivative of this. So there, that 2 up top is going to come out front. So this 2, this is the power rule that we learned, what, a week or two ago? You take that 2, drop it out front. I'll even write down. We have negative 0.25. And then times, we're going to bring the 2 out, and then x to the first power. So the power 2 came down in front. There it is. And then we subtracted 1 from the power, and we just get 2 to the x to the first power. Yes? Yes?
Oh, right, because no x.
That's right. No x. If it's constant by itself, derivative is 0. Okay?
Yeah. And the x just take, okay, I remember now. Okay, yeah, the power.
Yes? Who else? Yes, sir.
How did you get the 2?
This 2. It came from that 2 up there. The 2 comes out. Remember the power rule? The power comes out in front, and then you subtract 1 from the power. Right? So that's our derivative power rule formula. And I think if you look at your test, that was the last problem on the test, was you taking derivatives, right? Using the shortcuts. Okay. So now we have our what we call our marginal cost function. Now this is not the answer. This is not the answer. Right? And this is where things get just a little bit tricky. Okay? This is a little bit tricky. So let me see if I can't explain what we do next to get the final answer. This cost function looks something like this, all right? Because it's a parabola, it opens down, who cares? What we did in part A was we looked out at 50 guitars and 51 guitars, like that, okay? And we said, okay, hey, look, the cost of making the 51st guitar was some value, and the cost of building the 50 guitars is that. And we looked at the difference of those, and that came out to be 74.75, right? That's the difference going from 50 to 51. That's how much the cost went up. Understand? In order to approximate that cost, approximate it, what we're going to do is use the tangent line somehow. Okay? That's what the derivative is. So I want you to consider this for a second. If I were to tell you right now to take these 2 points and connect them with a straight line, do you agree that the slope of this straight line right here would be rise over run? That's your rise over run? Okay, how much do you rise by going from here to that point? What's that rise? 74.75, right? What's your run? What's the difference between here and here? 1, right? So isn't the slope of that little triangle line actually that number? Yes? What we are going to do is we are going to approximate the slope of that line with our tangent line. Now my question to you is, do I use the tangent line here, or do I use the tangent line here? Does that make sense? There's 2 different ones I could look at. So which of these slopes do I use to approximate the red one? Well, look at the formula. I already erased it, but, or I didn't erase it. It was never written. That was the equation I had up here a second ago, isn't it? So this says, we were doing this and we said C of 51 minus C of 50, right? We were trying to look at the cost of producing the 51st bicycle. 51 goes here, 50 goes here. So over here, this should be approximately equal to C prime of what? 50 or 51? So look at the formula. What's x in the problem? What's x here? 50, right? So we're actually going to be finding the derivative at 50, not at 51. That's where people kind of make a mistake. If we want to know the marginal cost, if we want to approximate the cost using the marginal cost function, if we're looking at the 51st guitar, we actually need to find the derivative at one before it. So we want here C prime of 50. And that means we're using this one right here is the one we're using, all right? The slope of that line is approximately equal to the slope of the red line. Yes or no? We'll do another example, but do you kind of get it? You got to, if you're looking at the 51st guitar, you kind of got to back up one and then use that in the marginal cost function.
So if it was like the 43rd, you looked at the 42nd.
That's right. So if it's 43rd, you go to 42nd. If it was the first guitar, you go back to 0. Okay? All right, so let's plug this in. We're just going to plug 50 into this boxed up formula right here. So 100 minus 0.5 times 50. And that's 100 minus, and that's 25 if you multiply these. And you get 75, right? $75. Now, would you agree that $75 is approximately $74.75? Yes? Right? You're off by 25 cents. But it's still close, right? And that's what this formula is saying. It's like, look, hey, for the most part, we can use the marginal cost function instead of having to compute the difference of these two things. All right? All we do is just take a quick derivative. Now that should be quick because we practiced and stuff. So we've got the quick derivative, then plug in the number, and we're done. Okay, what do y'all think? Yes?
If we're trying to find the approximation, what rounding
Rounding what?
Just because it worked on
This answer? Are you saying round this or?
74, 75.
No, that's the exact cost and we do not want to round it. Even if we got here 75.25, we would not round it. All right, let's continue. Normally, I can project the book up here electronically and not have to be using this stupid camera, but having some problems getting to the electronic copy of the book, so I apologize. It's the publisher changed something, and I guess I don't have an updated Java or something like that, so I'm having issues. All right, let's look at another one. Now this one's going to be challenging because I want us to read it upside down. Can y'all do that? Okay, good. I'm not going to tell you either. I'm not going to tell you which one, so you have to guess. No, hold on. All right, let's look at number 38. Y'all can move that desk if you want, like, so you don't have to sit sideways. Like, you can move it out. It's up to you. Y'all want to see something? Oh, you're going to see it anyway. So my students have been asking me, have I been painting? Because I've got paint all over me. Right, and so what's that? No, I didn't. I built something, and I've been working on it for like 2 months, and I finally finished it last night. So I'm gonna show you the picture of it. So I built this. I'm pretty proud because I've never built anything like this before. Let's see if that.
Wow.
What do you think?
That's really nice.
Whoa! What happened? Why did it do that?
It's not proud of you.
Whoa! It's like some copyright, I guess. It won't let me show it.
You built a TV?
Yes, I built the TV. I built the whole thing. Why is it not doing that? It's weird.
Earlier. It's what it did with the book. It's like focusing in or something.
That's weird. Yeah, Pretty good, huh? I think it's a glare. I guess that's saying get down to business, stop jacking around. Yeah, it was fun. It was fun.
By yourself?
The whole thing, everything you saw there, like the shelves and then the fireplace and everything. Yeah. The hardest thing was paint. That's the hardest thing.
You didn't tape
It's,
it?
paint, because you can screw that up real easy. I'm starting to build up my own because I want to do this on the side.
Extras, tons if you want.
But I'll take everything you have. No, I'm just kidding. Okay, here we go. Profit analysis. All right, total profit in dollars. So now we're talking about profit, not cost, right? Y'all see the function here? All right, so it says find the exact profit from the sale of the 41st calendar. We're selling calendars. Because you know how people, they buy calendars all the time, right?
I mean,
Yeah.
I worked at the
Do you? Oh.
like at the mall.
Oh, like during the holidays, right? Like,
Yeah.
around Christmas.
Yeah, we have family friends that like
All right, so part A. What are we going to do to calculate part A?
We're gonna plug in 41. and
Yes?
40 on the other one.
And subtract the two.
Right.
Exactly. So they're asking for the exact profit. So what we want to do here is we want to take the profit that we would get from selling 41 calendars and subtract from it the profit that we would get from selling 40 calendars. Okay? And that will give us the profit of selling that 41st calendar. All right, so we get to plug in. Great, wonderful. So this is going to be something here minus something here, like that. So we plug in 41 first. So it's 22 times 41 minus 0.2 times 41 squared minus 400. So this is just what we consider in math plug and chug. You're just plugging things in, chugging out the answer, right? There's not a whole lot more for us to do other than compute this stuff. Our answer should be $5.80. So I'm not going to go through this. I'm trusting that somebody is already punching away at this and that they can verify for us. So if you do get $5.80, let me know. No one's doing it. No. Yeah, for everything, yeah. So you should practice this on your calculator because you don't want to be sitting there first time during the quiz or test or whatever and using your calculator for the first time to do something like this. So let's wait until we get at least one person to verify. Yes, you got 580. Okay. So just be careful with all your signs, right? Especially this negative sign has to get passed through, right? Okay, so that's part A. Part B, what do we do? Read the question, right? Use the marginal profit. So as soon as you see the word marginal, you're thinking what? Taking the derivative, right? You're thinking derivative as soon as you see marginal. So we are going to first take the derivative of the profit function. So p prime of x, that's our marginal profit. And let's see, what is it? 22, right? Because derivative of 22x is 22. And then we have to take derivative of this. Right? So the 2 comes out, right? So yeah, it's going to be 0.04, or it's going to be 0.4, but I'll bring the 2 out, and then that's x to the first power. And then what's the derivative of 400? 0. So this just becomes 22 minus 0.4x. See, the idea here is that taking the derivative and plugging a number in is easier than what we did up here. I'm not necessarily easier, but I guess we have room for less error than we have up here. We can make a lot of mistakes up here. Plus, think about this. Once we have this answer, then we can find the marginal cost anywhere quickly. We don't have to redo this every single time. All right, so that's not the answer to part B, right? What's the answer to part B? We have to go p prime, and what are we plugging in? 40. 40, not 41. Because when you do the marginal and you're looking at the approximate for the 41st calendar, you actually go back to the 40th calendar Do you see how that's a common mistake on the test? People will go P prime of 41, right? Okay, so when we plug it in, we get 22 minus 0.4x, not x, x is 40. So that's 22 minus, that's 16, which is equal to $6. It's pretty close, right? Within 20 cents. Okay, let me see if I can't convince you of the actual value of having this versus this. Because you might be like, well, it's better to have the exact than it is to have the approximate. But here's why it's more valuable. Because what if I asked you now to give me the cost of producing the 83rd calendar, or sorry, of selling profit. So if I asked you for the profit of selling the 83rd calendar, couldn't you approximate that very quickly by just plugging 82 right into here? Right there? Sorry, right here? Yes? And then what if I said the 100th calendar? You would plug 99 in here, right? It'd be a quick computation. If you did it this way, you have to go 83 minus 82, then plug it in, and then get an answer. And then if I said 100, you have to do 100 minus 99, plug it in, then get an answer. Do you see how just popping a number in here just over and over is much faster? Right? Okay. Yes?
I understand it's much faster, but wouldn't it be more beneficial to actually have the exact amount?
Well, there's an argument there. If you're just looking to see what the trend is, because right now, let's do it. Let me add a part C. Okay, what would the marginal profit be at 100? Okay, let's see. So that means I'm going to plug in here 99, right? So if we plug in 99, it's 22 minus 0.4 times 99. And what does that give me? Someone's going to have to do that for me. 22 minus 40. 1804 right here? Oh, right here. 1804? Yeah. And then you subtract that to, I can't do basic math, 396? But, wait, was this 18?
No, it should be 17.
No, that something is not right. Hold on.
Yeah, I plugged it in wrong. It's
Yeah.
17.6.
What is it?
17.6.
17.6. That's 0.4 times 99?
39.6.
Yes, something ain't right there. I don't know. What are you doing wrong? 0.4 times? Oh, 39.6. Oh, you're doing it you're already computing everything. I'm sorry. No, what was just this? 39.6. Okay, you weren't wrong. 39.6. And then you subtract, and when you subtract, that's where you get what? Negative 17.6. Okay. All right. Now, you were saying, wouldn't it be better to know the exact and everything like that? So what I might want to know for my company is whether or not I should be actually producing and selling this many calendars. What this is telling me is that at 40 calendars, when I produce that 40th and sell that 40th calendar, or the 41st calendar, my profit, right? My profit was actually increasing by $6. So my profit's going up, isn't it? But if I sell 100 calendars, my marginal profit for that is negative. And that's what's important.
Where do you get the market data on this? Because
Where do you get the what?
where would a company get this data saying 40? Where would they get those numbers from?
It's a great question. Because a lot of times in classes like this, we work with functions, but no one ever asks like where did the function come from, right? So what you have in real companies is somebody who's assigned to do what's called regression modeling. And what they do is they collect data. They say, okay, we sold this many, this was our profit. We sold this many, this is our profit. And once you have about, 10 data points, you can fit a curve to it. Okay? And so that curve, the type of curve you fit to it, you kind of get a choice. So like let's say we look at, we produce this many items, this was our profit, right? And we say, okay, when we did like 10, we had this much profit, then that much profit, and then maybe like that much profit, and then it started to come down. So we get a couple of data points. Maybe we look at last year's sales and things like that. And then what we can do is we can have a computer, or we can do it by hand, but it's terribly hard to do by hand. We can have a computer do a model that will not necessarily pass through every point, but it will fit into this data set and model it. Model it. All right? And then what we can do is the next year we can use that and say, hey, look, this was our model for what's going on with our business. And then we actually have this function, profit function.
What would be the area of uncertainty? What would be okay? What would be acceptable in that sort of situation?
For how much you're off by? Well, if you're looking at past data, you're trying to predict what's going to happen, right? So it doesn't have to be perfect, right? Doesn't have to be perfect. Now, the more data points you have, the better the model is, okay? And there is a way that you can, in theory, you could fit a curve through every single point, but it's very intensive in terms of the computation that it requires, and then your function becomes more complicated. It's not necessarily a parabola. So what we do is we can tell a computer, and actually your graphing calculators can do this. You give it a data set, you go to a regression menu, and it says, do you want to fit a line to that data, a parabola? Do you want to fit a cubic function? And it will go and fit a curve for you. And it'll tell you what the function is. Okay? So, and we don't do that in here. Like in statistics, you might, depends on the class. We used to actually teach a college algebra class that was all you doing that sort of thing. So that's a great question, because where do these functions come from? You just have to believe that they come from somewhere. Now, in the real world, the functions are not 22x. It's going to be like 21.753. You know, they're not. The numbers aren't as pretty. But the idea here is what we're trying to understand. If we had a profit function, could we use the derivative to somehow figure out what's going on as our sales or as our number of items sold changes? Okay, your question. I'm moving on.
And why does the pigs though use so much space, like whole process with the regional, or
Why does what?
why does the sales like be so 99 compared to 40?
You gotta take the market out what it looks like, how much materials cost, and at a certain point, you're gonna make so many that you're gonna lose profit. You're gonna have extras because nobody's gonna buy it.
Realistically, you wouldn't actually produce until the profit when you produce at where you have the maximum rate of change going up. So that's when you're going to profit. If you do that to the profit point, you stop making money really. So you don't actually go to that point. You go to this point.
Your goal is not to have your stuff sold at Ross. Yeah.
Your goal is not to have your stuff at Ross. Is that what you said?
Doing good.
Yeah. Come on.
You want your stuff there.
I'm so sorry about this archaic technology here. It's driving me crazy. Almost there. All right, let's look at number 44. Okay, so 44 is a more involved problem. There's a couple of other things happening here that we have not discussed. Revenue analysis. The price in dollars and the demand X for a particular steam iron are related by this equation. Let me write this down. X is equal to 1,000 minus 2P. So keep in mind here, P is the price.
2 or 20?
It's 20. Maybe you need to move where you're sitting. There was a 20 there. You didn't see that? Price. Okay, price per item. And X is the demand, right? demand. Okay, let's just start by looking at this and understanding what this equation is saying. My company is selling steam irons. They're hot. I mean, they're literally hot. Okay, people want these, right? This equation is relating the demand, which is how many people want, to the price in which I'm going to sell them for. So according to this model, if I set my price at $0, what's the demand? According to this model,
You said 0, 1,000?
if I set my price to 0, my demand is 1,000.
If it's free, everybody really wants it.
Well, yes, but in my model, so the model actually probably should account for that, but you know, yeah, you're going to have a much higher demand if it's free, right? But we know that P is never going to be 0. So what if I set my price at $1? 9,080, right? 980, yes, 980, sorry. So as I adjust my price, my demand starts to change, right? And it seems like the higher the price, the lower the demand. Yes? All right, so I just want to make sure you understand that that equation connects your price and your demand together. Again, this is a model, so someone has come up with this. Our guy in there with the math guy in there has come up with our model, all right? Okay, now let's continue. Express the price in terms of the demand, and then find the domain of this function. We haven't even talked about domains. We talked about 1324 though. So let's start this out. This equation up here, this expresses the demand in terms of price, right? You give me price, I give you demand. Part A is saying express the price in terms of demand. All that's saying is to solve for P, to take this equation and solve it for P. All right? Can we do that? Can we solve that equation for P? All right. How about, why don't we do this? Why don't we subtract 1,000 on both sides of that equation first?
Wouldn't it be easier because it's negative 20 just to...
You could move the 20 over and then the x over. It's up to you. It's all going to come out the same. So all I did was took this equation, subtracted 1,000, got this. Now I'm going to divide by negative 20. So I'm going to go negative 20 here and negative 20 here, right? Okay, so watch this because this next step's important. Price is equal to x over negative 20 minus 1,000 over negative 20. So I've split this up into two fractions. Is that fair for me to do that? I do x over this and I do minus 1,000 over this, right? Okay, one more step. I mean, I've already solved for P, haven't I? I've got P by itself, and P is in terms of x. So now if you give me x, I give you price. But let's clean this up a little bit. Can we rewrite this as negative 1 over 20 times x, and then plus, what's 1,000 divided by 20?
50.
50?
Yeah.
And that equals P. Now, why do you think I wrote this x over negative 20 as negative 1 over 20x? Why would I have done that?
So we can isolate the x.
We can isolate the x, but wouldn't it be easy to take the derivative of this? Like later on, I might take the derivative, and it's easier to say, oh, look, what's the derivative of this? What is the derivative of this? Negative 1 over 20, right? Because the derivative of x is 1. So we get into a habit now of trying to rewrite things like this instead. So this is it. Have we expressed the price in terms of the demand? Is the price in terms of demand? You give me demand, I give you price. Right? So if you give me a demand, if the demand is 0, right, according to this, if the demand is 0, nobody wants my stuff, I'm going to set my price at 50. That's what the model says, right? What if I have 20 people that want my steam irons? What if 20 people want them? 20 goes here, right? And then what's 20 times negative 1/20th? That'd be negative 1. And then plus 50, I'm going to set my price at $49. Okay, so if I have about 20 people that want my irons, I set the price at $49. All right, now we haven't answered the domain part.
Isn't that X, right?
What?
Isn't domain X?
Domain is, it is asking what X is, but it's saying what X's make sense. So would you agree that we would never want to set our price to be negative? Because then it wouldn't make sense, right? What if I'm sitting here, I'm like, hey, yeah, my phone, or, you go to the store, your phone's like negative. Where did my phone go? Oh, there we go. Right? Like, negative $50, right? It doesn't make any sense. So how do we guarantee ourselves that our price is not negative?
Leave it 0? Or make it greater than...
Yeah, so what we're going to want to do is we're going to want to take this, and let me erase this up here. So to finish off and talk about the domain of this, so for the domain, I want price to be greater than 0, right? That makes sense to have our price greater than 0. So that means I'm going to take this equation, negative 1 over 20x plus 50, that's price, and I want it bigger than 0. So how do we do that? How do we solve this inequality? This is, again, a 1324 concept. This is a linear inequality. We can work with this algebraically. We can subtract 50 on both sides. Right? That would move this over, right? I'm trying to solve for x right now. How could I get rid of this right here? Multiply by what? Negative 20. Negative 20 on this side, negative 20 on that side. Okay? But there's something that important happens when you multiply by negative in an inequality. Do you all remember? It flips it. Okay? You have to remember that, or else you're going to find yourself in trouble here. If you have an inequality like this, and you multiply both sides by a negative number, the inequality flips. So I'm going to multiply this side by negative 20, multiply this side by negative 20, and then this is going to flip. And when that flips, my new statement is this. The whole reason we did that is because that's 1. So we get x there, 1x. This flips less than, and then this side's what? 1,000.
Whenever you multiply negative?
Only if it's multiply or divide. So that only works with inequalities. If you have a symbol, you multiply or divide both sides by a negative number, the inequality must flip. And that has to do with the property that when you multiply two negatives, you get a positive. And so it changes the way it faces. Okay? This is the domain, all right? Let's please interpret what this is saying. If we want our price to be positive, right, then what has to be less than 1,000? What's x?
Demand.
The demand. Okay? So for our model to make sense, we need less than 1,000 people wanting our irons. Okay? If we get a higher demand, we're probably going to have to change our model because our price demand equation doesn't really fit very well. Yeah. We're doing a lot of waving of our hands here, which means that we're just trusting that a lot of these things that are given to us, that they work for our situation. How to get those, that's a much deeper question. Yeah, it's beyond the scope of this class. That's why this is only the second class in a business track. If you want, MBA or you want to go all the way with business, eventually you have to be the one coming up with the functions, right? But it's important at this level to understand what you do with them once you get them, what you can do with them. All right. Okay, now part B. Find the revenue from the sale of X steam irons. And put a star next to this. If you were trying to explain to somebody walking on the street what revenue was, what would you tell them?
Money after cost of purchase that you have to sell.
So revenue is the money that you have
Minus the cost of the item.
minus the cost?
Cost plus profit.
Cost plus profit?
Isn't it, it's the difference you have from your profits and your, what's the word, other one?
I'm talking. That's the way you talk to your friends. You'd be like, "It's cost minus profit." Like,
I would literally tell them.
how much money you make? How much money is left?
I just tell them, literally tell them the actual thing. Like, I tell them it's your
Isn't
total,
revenue just?
it's your total and your profit subtracted.
Okay, so look. I'm gonna do this visually. Okay. You work for me, okay? You're buying our stuff. All right, here's your money. All right. Okay. I'm going to sell some stuff. Here I go. I'm selling stuff. That right there, keep coming. Keep coming. I want all of it. That right there is called our
Profit.
revenue. Revenue. Okay? Revenue. Revenue. I'm going to pay you for working. That's profit. Okay? Revenue is the money coming in. You're not even thinking about paying your employees yet, right? This is my cost, right? This is my profit. So there's a big difference between revenue and profit. Understand? And that's why the equation for profit is revenue minus cost. It's the money you bring in, thank you very much. Take out the money that I need to pay my employees, pay the electric bills. Everything that's left is mine. Now, yes, you could move things around on this. You could do revenue is equal to profit plus cost. That would just be adding C to both sides. So there's different ways to look at this. But at the end of the day, did I do that right? Wait a minute, what did I just do? Revenue, no, I just screwed that up. No? P plus C, yeah, that's right. Okay, so I want you to think about revenue as just the money coming in, right? The money coming in. It's the money coming in. So let's go back to this, because that was fun, right? Did you enjoy that? Okay. Okay, so now, if I'm going to try and come up, because look, in this problem, it's asking us for the revenue. Find the revenue function. You aren't given the revenue function, are you? Right?
Isn't that right there?
No, no. That's the standard equation for the relationship between revenue, profit, and cost. The only thing we're given in this in this problem is that right there, and that's our price-demand equation, right? So now we want to know what the revenue is. Okay? So I need to sell you something. I'm going to sell you markers. All right, here we go. So here are my markers, right? I have set a price for these, right? I've set a price. And how many do you want?
3.
3? Okay. So how much revenue am I going to take in from that? 3 times what?
3 times the profit.
3 times,
Cost, right?
no, 3 times the price. 3 times the price, right? Yes?
Yeah.
Okay. That's why this equation you have to know. Revenue is equal to XP. What does that mean? It means my price has been set, right? Those were $3 a piece, right? And no, you bought 3 of them, sorry. 3 markers, right? Times the price is how much money is going to come in. So this equation is the items, that's your items sold, and then this right here is the set price. If I sell 100 iPhones at $1,000 a piece, my revenue is going to be 100 times 1,000, right? It's going to be the number of items I sold times the price I sold them at. Understand how the revenue equation comes from, where it comes from? Okay, so for us in this problem, our revenue is going to be the items sold, X, times the price. But weren't we given a price function or a price equation? No, we kind of were, weren't we? What did we do on part A? We solved this for P, didn't we? Why do you think we solved that for P? So we can plug it in right here for price. Okay? So what was our P from part A? It was negative 1 over 20 x plus 50. See, that's the P from part A. Did you all see that? Our revenue is the number of items we sell times the price per item. So would you agree with me now that we actually have a revenue function? Like this revenue depends only on x. And I can distribute the x through, and I can get negative 1 over 20 x squared plus 50x. And this right here is our revenue function. It's critically important that you understand that if you're given a price-demand equation, that you can always generate the revenue function from it. You have to solve it for P first, solve that for P first, and then plug it right into this formula. Once you do that, you have your revenue function. Questions? It asks for the domain of this revenue function. That's part B. It's, what's the domain? Well, the domain for this is the same as the domain that we got in part A. Remember, our price had to be greater than 0? And we said that meant our demand, our X, had to be less than 1,000. So this revenue function works so long as this makes sense. And that only makes sense if that's less than 1,000. Right? Our price only makes sense if the number of people who want it is less than 1,000. So that's our domain.
Just like you only have 1,000 or whatever it is you're selling. Like you only have 1,000. It's just like, dang, I don't know. There's no other situation where like you wouldn't want to make more money from there.
Well, what are we selling here? Irons. I mean, maybe you can't manufacture 1,000 irons. Maybe you don't have the resources for that, right? So your model is good because or not 1,000, but maybe you live in.
Sounds like you're selling them out of your trunk when you go to 1,000 of these, man. Like I only have 1,000.
Yeah. Well, be careful. This 1,000 is the number of people, though. Remember, this is not. Right? The number of items you're going to sell, right? You want that demand to be less than 1,000, which means the number of people that you want to actually buy is less than 1,000, which is the number of items, right? I mean, I see what you're saying, but keep in mind here, these problems are just for understanding the concept. Yes, like what company is going to have less than 1,000 of anything, right? Yeah. Okay. Well, Tesla?
Louis Vuitton, Chanel.
I mean, how many Tesla vehicles are manufactured a year? You know what I'm saying? Like, I mean, there are certain things out there that they don't make many of them, and they do that because then they can charge you a lot. Okay, let's move on to C. Hey, part C, not bad. Find the marginal revenue. You know what? See if you can do part C. I've got to take this call.